Welcome to our channel, where we bring you the most interesting and informative content from around the world. Look up at the sky. Have you ever wondered about the vastness above us? The stars, the planets, and the endless expanse of the universe? It's a mesmerizing sight, one that has captivated humanity for millennia. The sun rises in the east and sets in the west. This daily ritual is something we often take for granted, yet it is a fundamental part of our existence. Each sunrise brings a new beginning, and each sunset marks the end of another day. This happens because our planet is constantly spinning, like a top dancing on its axis. Imagine a child's toy, spinning endlessly, never losing its momentum. That's our Earth, tirelessly rotating, creating the rhythm of day and night. We call this movement Earth's rotation. It's a simple term for a complex and vital process. This rotation is what gives us our sense of time, dividing our days into light and darkness. This rotation is fundamental to life as we know it, dictating day and night and influencing everything from weather patterns to ocean currents. The spinning Earth affects the winds, the rains, and even the way our oceans move, creating currents that sustain marine life. Earth's rotation is a continuous movement, a never-ending spin that has been happening for billions of years. From the moment our planet formed, it has been in motion, a dance that has shaped the very fabric of our existence. This spin is not something we feel directly, like the rumble of an earthquake or the rush of wind. It's a silent, invisible force, one that we can only observe through its effects on our environment. Instead, it's a silent, invisible force that shapes our world in profound ways. From the gentle sway of the trees to the powerful currents of the oceans, Earth's rotation is a constant, guiding force in our lives. It reminds us of the delicate balance that sustains life on our spinning world. Imagine a basketball spinning on your finger. The ball twirls effortlessly, maintaining its balance as it rotates. This simple act is a perfect example of rotational motion, a concept that is fundamental to understanding how objects move in a circular path. Every point on the ball makes a complete circle in the same amount of time. Whether it's the top, bottom, or any point in between, each part of the ball follows a circular trajectory, completing one full rotation simultaneously. This is the basic principle of rotation, a circular movement around a fixed axis. The axis is the imaginary line that the object spins around, and it remains constant as the object rotates. The Earth rotates on its axis, an imaginary line passing through the north and south poles. This rotation is what gives us the cycle of day and night, as different parts of the Earth face towards or away from the sun. This axis of rotation is not perfectly straight up and down but tilted at an angle of about 23.5 degrees. This tilt is crucial for the diversity of climates and weather patterns we experience on our planet. This tilt is what gives us our seasons. As the Earth orbits the Sun, the tilt causes different parts of the Earth to receive varying amounts of sunlight at different times of the year. As Earth spins, different parts of the planet receive varying amounts of sunlight throughout the year, creating a dynamic and ever-changing environment. This variation in sunlight is what drives the changes in temperature and weather patterns, leading to the familiar cycle of spring, summer, fall, and winter. Each season brings its own unique characteristics and changes, from blooming flowers in spring to the falling leaves of autumn, all thanks to the Earth's continuous dance of rotation and tilt. Our planet is not a perfect sphere. It's slightly wider at the equator and flatter at the poles. We call this shape an oblate spheroid. This shape is important because it means that points on the equator have a longer distance to travel in one complete rotation compared to points closer to the poles. Think about it like running a race. If you're running around the outer edge of a circular track, you'll cover more ground than someone running on a smaller, inner lane. Similarly, a point on the equator travels a greater distance in one rotation than a point near the North Pole. Imagine swinging a ball tied to a string. As you spin it, you feel a force pulling outward on the string. This force is called centrifugal force. It's the same force that pushes you to the side when a car makes a sharp turn. Earth's rotation also creates centrifugal force. This force is strongest at the equator, where the distance traveled in one rotation is greatest. The centrifugal force is weaker at the poles because the distance traveled is shorter. Section 5. From equator to poles, a change of pace. Because of the Earth's shape and the centrifugal force, the speed of rotation is not the same everywhere on the planet. The equator, being the farthest point from the axis of rotation, spins the fastest, at roughly 1,000 miles per hour. As you move towards the poles, the speed gradually decreases. This is because the circumference of the Earth gets smaller as you move away from the equator. At the poles themselves, the speed of rotation is essentially zero. Section 6. Whizzing through the atmosphere, weather and rotation. Earth's rotation has a profound impact on our weather patterns. One of the most significant effects is the Coriolis effect. This effect causes moving objects, like air masses, to curve as they travel across Earth's surface. In the northern hemisphere, the Coriolis effect causes winds to curve to the right. In the southern hemisphere, winds curve to the left. This deflection of winds influences the formation of large-scale weather systems, such as hurricanes and cyclones, which spin in opposite directions depending on the hemisphere. Section 7. Time flies when you're near the equator, travel and rotation. The difference in rotational speed between the equator and the poles has a subtle but measurable effect on time. According to Einstein's theory of relativity, time slows down slightly in stronger gravitational fields. Because the centrifugal force is stronger at the equator, the effective gravitational pull is slightly weaker. This means that time actually moves a tiny bit slower at the equator compared to the poles. The difference is minuscule, only a few nanoseconds per day, but it's a real phenomenon. You might wonder why the Earth doesn't simply fling itself apart with all this spinning. The answer lies in a delicate balance of forces. Gravity, the force that pulls everything towards the center of the Earth, acts as a counterbalance to the outward push of centrifugal force. Gravity is a much stronger force than centrifugal force. It's what keeps our planet together and prevents us from flying off into space. This balance between gravity and centrifugal force is essential for maintaining Earth's stable shape and rotation. Earth is not the only celestial body that rotates. In fact, almost everything in space spins, from planets and moons to stars and even galaxies. The speed and direction of rotation vary widely depending on the object's size, mass, and history. Our Sun, for example, rotates on its axis about once every 25 days. However, the Sun's rotation is not uniform like Earth's. Because it's a giant ball of gas, different parts of the Sun rotate at different speeds. This differential rotation plays a role in the Sun's magnetic activity, which can lead to solar flares and sunspots. Earth's rotation is a fundamental aspect of our planet's existence. It influences our daily lives in countless ways, from the rhythm of day and night to the patterns of our weather. It's a testament to the intricate workings of the universe, where even seemingly simple movements can have profound and far-reaching effects. As we continue to explore and understand our place in the cosmos, it's essential to appreciate the fundamental forces that shape our world. Earth's rotation is not just a scientific fact, it's a reminder of our planet's dynamism, its constant motion, and its interconnectedness with the vast universe around us. Our planet is a spinning sphere, a celestial dancer whirling through the vastness of space. This constant rotation is a mesmerizing ballet that has been ongoing for billions of years, ever since the Earth first formed from the dust and gas of the early solar system. This rotation, a fundamental characteristic of Earth, dictates the rhythm of our days and nights, shapes our weather patterns, and even influences the flow of time itself. As the Earth spins, it brings about the cycle of sunrise and sunset, creating the beautiful transitions from day to night that we experience daily. The rotation also plays a crucial role in the formation of weather systems, driving the winds and ocean currents that regulate our climate. From the equator to the poles, the speed of this spin varies, a testament to the interplay of forces that govern our planet. At the equator, the Earth spins at its fastest, completing a full rotation in just under 24 hours. However, as you move towards the poles, this speed decreases, illustrating the complex dynamics of rotational motion. This variation in speed is due to the shape of the Earth, which is not a perfect sphere but an oblate spheroid, bulging slightly at the equator. As we've explored, the Earth's rotation is not just a solitary phenomenon. It is part of a larger cosmic dance, influenced by the gravitational pull of the Moon and the Sun. The Moon's gravity causes the Earth to wobble slightly on its axis, a motion known as precession, which affects our planet's orientation in space over long periods. It's a reflection of the interconnectedness of the cosmos, where celestial bodies from planets and moons to stars and galaxies are engaged in their own intricate dances of spin. Each of these bodies, whether a small moon or a massive galaxy, follows the same fundamental principles of physics, creating a harmonious and interconnected universe. The rotation of planets and stars generates magnetic fields, influences their atmospheres, and even affects the potential for life. Understanding these forces allows us to appreciate the delicate balance that sustains our world and deepens our connection to the universe we inhabit. By studying the rotation of Earth and other celestial bodies, we gain insights into the fundamental workings of the cosmos, revealing the intricate and beautiful patterns that govern our existence. This knowledge not only enhances our appreciation of the natural world but also inspires us to explore further, seeking to uncover the mysteries of the universe and our place within it. Thanks for watching. Don't forget to subscribe, like, comment and share.